COVID-19 has really affected the entire world. And in the Philippines, the recent update shows that we are also affected by a new variant of the virus. Although vaccines and vaccination is still ongoing, PCQ is still happening because of these new variants, and the country is nearing 2 million in the number of COVID-19 cases. This has resulted in what we now know as the new normal. One of the new normal protocols is regular body temperature monitoring, which is required at every entryway because body temperature is an indication of symptoms. And the most common way to do this is using a thermal scanner. The problem with this method is that it is slow, people line up, and social distancing is not maintained. Data are often not saved, and temperature readings can be inaccurate. So we offer a technology for the new normal. So hi, I'm Erwin Enriquez from the Ateneo de Manila University. And with funding support from PCIEERD UST, together with our partner, SparkSoft Solutions Incorporated, we offer baTID, which is an RFID band for personalized body temperature monitoring. And the advantages of this is that it is a wearable device that provides identification and at the same time temperature of the wearer. And the information can be saved in a database, and members of organizations such as in schools, workplaces, factories, and condominiums will benefit from this because it is faster, it has more accurate reading of the body temperature, it's social distancing compliant, and also more importantly, the information can be linked to contact tracing systems. In order to make the device cost effective, we use printing as a way to manufacture it. So this is one of the major components of our research, to be able to print a major component of the device, which is the RFID antenna. So as shown in this video, printing is an emerging technology to manufacture electronic devices. This is actually classified as additive manufacturing process because you only use materials where it is needed, such as shown in the schematic. For example, when you go to a tailor to make your clothes, the tailor cut away pieces of the cloth to be able to come up with a final design. So that is subtractive. In additive manufacturing, you don't waste materials. Because our project is still ongoing, so let me just share with you some of our results. So of course, because we are printing, we have to use inks. So we use metallic inks so that we can make the hybrid device. The metallic ink is used for printing the antenna, which is a major component of the baTID band. So for our research, we have used commercial silver ink. And fortunately, we also have our own formulation, but this is made of gold ink. The gold ink is made up of very small particles or nanoparticles of gold, and we find this quite useful in our fabrication. Because printing of devices is still an emerging technology, so we encounter problems such as, for example, a poorly adhered antenna. But we have been successful in making a strongly adhered antenna, such as shown in this video. So this is very useful because we need to make a reusable device for the purposes of the baTID device. We already have a successful prototype such as shown here, so which can read the temperature and the identification. In order to ensure that the device is acceptable to many, so we've done a market survey, and our respondents showed acceptability and likability, and they have a perceived importance of the device and will be likely to buy or recommend it for use. So we do hope that when this technology is available, that you will use it so that it will help us in coping with the new normal. And of course, we would like to thank the support of the UST for funding this research.